This is question 18 from section 1 of the 2018 BMAT. In this question we have 8 Skittles, so 4 yellow and 4 red, and 6 places to put them in, arranged in a triangle, and we're asked how many different arrangements are possible. So if you look at the options, they range from 20 to 70, so that's quite a lot. It would take you a long time to try to draw them all out, and how can you be sure you haven't missed any? So let's try and find a way to do this as systematically as possible and maybe simplify the problem for ourselves. Okay, so you can do this by thinking about what the different arrangements will be. So trying to think, how can I fit the yellows and the reds in this pattern? Or you can do it by calculation, which is what I'm going to do because it's much quicker. Whichever of those ways you choose, though, it can get confusing to have the 6 places be in this triangle shape. I think it's easier if the first thing we do is we just put them in, we label them 1, 2, 3, 4, 5, 6, and then put them in a row. And then what are we trying to do? Well, we've got to choose 6 Skittles to go in these 6 places, and our problem is there's 8 Skittles. And the numbers of reds and yellows we get is going to be important, because say I have 4 yellows and 2 reds versus having 3 yellows and 3 reds, I'll always get a different arrangement with 4 and 2 because the colours are different. So what are the different sets of Skittles I can have? What are the different sets of 6 Skittles? Well, I can either have 4 yellow and 2 red, or 3 yellow and 3 red, or 2 yellow and 4 red. And there are no more options because I can have at most 4 of each. So I've just labelled these cases A, B and C. So now let's try and use this way of thinking about things to do a calculation. Okay, so I'm going to use a formula that might look unfamiliar, but you'll see as we go through why it's correct. But I'll just explain what it says first. So the total number of arrangements is basically the number of ways of ordering 6 things, if we know nothing about them, not even their colour, divided by, open brackets, number of ways of ordering the red Skittles in particular, times the number of ways of ordering the yellow Skittles in particular. So that might not make sense, but we'll see why that's applicable in a second. When I talk about the number of ways of ordering, let's talk about this term first, number of ways of ordering 6 things. If I'm just ordering, say, n things, so n is any number, what's the number of ways of doing that? Well, it's actually the product of all the numbers up to n, so 1 times 2 times 3, etc., all the way up to n. I've written this the other way round. Why is that? Well, because if we want to see why this is true, let's do it with 6 things. So with 6 things, suppose I have 6 things I'm going to put in 6 places, and we might think of it as a number 1 to 6. Well, how many things can I put in the first place? 6. But once I've put that there, I've got 5 things I can put in the second place. And once I've placed those 2, there's 4 left, so I've got 4 things I can put in this place. Then 3 in this one, then 2 in this one, then 1 in this one. And then for each of the 6 things I put here, there's 5 different things I can put here. So that makes 30 things, 6 times 5 for the first 2. And it's going to be 6 times 5 times 4 for the first 3, etc. So our total number of ways of putting 6 things in the 6 places is 6 times 4, 5 times 4 times 3 times 2 times 1, which is 720. And if I had had, say, 100 things or 3 things or any other number of things, so n things, we'd have the same process. So you've got n choices here, then n minus 1, and n minus 2, etc., all the way down to 1. And that's why this is the number of ways of ordering n things. So with that in mind, let's look at each of our 3 cases. So case A is where we had 4 yellows and 2 reds. And I'm saying to put these things, to count number of arrangements, I want to count number of ways of ordering the 6 Skittles, and then divide by something. Why do I need to divide? Well, suppose I space these things out so they're a bit easier to move around. And then suppose I just pick some arrangement, so I could put the red ones in here, for instance, and that's some arrangement of yellows and reds. So we might think, well, there's 6 Skittles, so we just count the number of ways of ordering 6 things. Why isn't that the answer? Well, because suppose I had, say, taken this yellow one and put it at the end here, and then maybe I'll move them up to make it look tidy. Now I actually have the same pattern as before, but if we were treating these as 6 things, so like if the Skittles had names 1 to 6, then this would count as a different order, but it looks the same arrangement because all we care about is the colour. So if I counted the number of ways of ordering 6 things, I would have just counted the 2 arrangements I've just shown as 2 separate things, but they should actually be 1. And that's because any way of changing the order that keeps the colours the same will have been counted as a separate thing, even though it doesn't count as a different arrangement. So that means that the number of arrangements I count, if I just call it 720, has been increased by the number of ways I can reorder the reds and yellows. As in the number of ways I can switch 2 red things or switch the 4 yellow things about. Because doing either of those things doesn't change what it actually looks like. So that's why we need to divide by the number of ways of switching the reds around, which is actually the same as the number of ways of ordering the reds. Because each switch just corresponds to a different order. So for instance, in this case, the number of ways of switching the reds is just going to be 2. I can swap them over, or I can swap them back. There's only 2 ways of ordering them. The number of ways of ordering the yellows is going to be larger because there's four of them, so I need to count the number of ways of ordering 4 things. So with that in mind, we just have to now count the number of ways of ordering 4 things, number of ways of ordering 2 things. Number of ways of ordering 4 things is 4 times 3 times 2 times 1, so it works out as 24. And number of ways of ordering 2 things is 2 times 1 is 2. So we're going to do 720 divided by this times this. And if you work that out, that comes out as 15. And then let's do the same thing for B. So B, we have 3 yellows and 3 reds. Now, the number of ways of ordering 6 things stays the same, but the numbers of reds and yellows have changed, so these numbers will change. So how many ways are there of ordering 3 yellow things? That's what 3 times 2 times 1 is 6, and the same for the reds. So 6 for each, and then we're going to do 720 over 6 times 6, and that works out as 720 over 36 is 20. And then for C, what do you think is going to happen? Well, we could just work out the answer again, but actually it's useful to see that the answer has to be exactly the same as for A, and that's because C is the same as A with the colours reversed. So if we take any of the arrangements we can get from A, and then just turn every yellow to a red and every red to a yellow, we'll have the same number of arrangements, and that will be exactly the arrangements you can get from C. So our numbers for C will be the same, just the other way around, and then we also get 15 out for C. So what's our total number of arrangements? Well, it's just the sum of these 3 numbers. So 15 plus 15 plus 20, and that works out as 50, which is answer E.